Today you're going to be working on lesson 3.3, complex numbers. We're going to rewrite square roots of negative numbers using as imaginary numbers. So the key concept there is that we had to figure out how to deal with the square root of a negative, because if you put that in your calculator, so square root of -1, you get an error message, non-real answer, because the answer is imaginary. So when we do the square root of -1, they came up with the fact that that is I. Okay? So we're going to also add and subtract complex numbers. So in your math studies so far, you've worked with real numbers. However, some equations like x squared plus x plus 1 do not have real solutions. So if we look at this function on the right, this parabola never crosses the x-axis. That's why there are no real solutions. So your first blank spot here is solutions. The imaginary unit I is the principal root of -1, as we said up here. So square root of -1 equals 1. Or square root of -1 equals I. Sorry, I said that wrong. So we also need to know the fact that if we have I squared, that equals -1. So in turn, if we have I cubed, that's like saying, right, we know I squared equals -1. So we have -1 times another I, which would be -I. So I would recommend memorizing what I'm about to highlight, this right here, as well as this. This, I believe you can just figure out, so you don't need to memorize. Okay? So we also want to look over here at our perfect square cheat sheet, right? So the square root of 9 is 3 because 3 squared equals 9. Square root of 16 is 4 because 4 squared equals 16, and so on. So if we look at the square root of 16, what I want to think about is the biggest factor of 16 that I can square root. So let's plug this into the graphing calculator. We can always do this trick, right? So if I do second square root, I'm going to leave off the negative. Or I'm sorry, we want to do 16 divided by x. That is not 16. 16 divided by x, and then we want to hit second graph so we can see the factors of 16. And then I look at this list, normally the list over here, and the biggest number I can square root is 16. So when I divide this out, I like showing it like this. I always write the one I can square root first, and then we have that -1 left over. The square root of 16, as we can see over here, is 4. So square root of 16 is 4, and the square root of -1 equals I. So the answer to the square root of -16 is 4I. Then we look at the square root of 20. Let's put 20 divided by x in the graphing calculator. So I'm going to put that in. I'm going to hit second graph to see the factors of 20. So I'm looking at this list down here to find the biggest number I can square root, which is 4. So we come back here, and when I divide this thing out, I'm going to say square root of 4. I can't square root -1, and I also cannot square root the 5. So we have 3 branches that time. So if I look here, the square root of 4 is 2. We know the square root of -1 is I, and the square root of 5 we can't do, so you just leave it alone. So again, we're going to break this one out to 3 different branches. So if we look at square root of 75, I'm going to hit my y equals I'm going to delete that and put in 75, then hit second graph. And I'm looking for the biggest factor of 75 I can square root. Obviously not with the decimal point, but there you see it. So we're going to break apart square root of 25 or square root of 75 into square root of 3 and square root of 25, as well as square root of negative 1. So again, I write the one I can square root first. I always put negative 1 in the middle, and then I have the square root of 3. Because 25 times negative 1 times 3. Remember, this is all multiplication in between these. So square root of 25 is 5. Square root of negative 1 is I. And we can't do the square root of 3. So this is really standard form of this type of concept. You write the number you can square root first, the I next, and the number you cannot square root last. That's how we want to see it every single time. So if I look at square root of 31, 31 here is a prime number. There are no factors of 31 other than 31 and itself. But let's look at it. It's worth double checking, right? In case your brain goes down the wrong path. And if I look at that, there's no every other factor of 31 is a decimal. So that's how you know it's prime, because 1 times 31 is 31. There's no other 2, 3, 4, 5 don't work. So this is one kind of like example 1 here, where we only have 2 branches. So square root of negative 1, square root of 31, because I know square root of negative 1 is I, and square root of 31 I cannot do. So we're done. That's it. Now, when you multiply 2 square roots together, remember you can multiply anything together. So we can multiply negative 10 times negative 15. So you can always double check in your calculator, right? Negative 10, go back to the home screen. You do second mode to do that, clear anything out. If we do negative 10 times negative 15, we get 150. So this equals the square root of 150. Now we have to break apart the square root of 150. We don't have to deal with a negative anymore, okay? So actually, we need to break it apart like this. I take it back. So we're going to break apart both these first because we have to simplify what's under the square root first. That's how we follow the order of operations. So we have square root of negative 1 times square root of 10. We have square root of negative 1 times square root of 15. So we get I times square root of 10 times I times square root of 15. So looking up here, we're going to end up with I times I, which is I squared, and then 10 times 15 is 150. So if we look up at the top of the lesson, we can see that I squared equals negative 1. So we have negative 1, and then I'm going to break apart square root of 150. But first I'm going to plug in 150 divided by x into my graphing calculator. Then I'm going to hit second graph so I can see the factors of 150, and I'm looking for the biggest factor that I can square root. Can't square root 75, can't square root 50, can't square root 30, but I can square root 25. So we're going to break apart 150 into square root of 25 and square root of 6. So I'm just going to move my negative 1 down a little bit. So we have square root of 25, square root of 6, and then I have that negative 1 I already dealt with because that's what I squared equals. So the square root of 25 is 5, so negative 1 times 5 is negative 5, square root 6. All right, so now we're going to look at solving equations. We're going to solve for x, right? So we're solving equations with imaginary solutions. So if I solve for x, first thing I have to do is get rid of the 27. So I subtract 27 from both sides. Then I get 3x squared equals negative 27. I'm trying to get the x by itself, so I have to get rid of this 3. I do that by dividing both sides by 3, and I get x squared equals negative 9. Now the way you undo a square root is by taking the square root of both sides. Anytime you squared a number, you must have a plus or minus in front. Okay, so we're going to get two answers. So over to the side, I'm going to break apart square root of negative 9. Again, we can square root 9, so we just have two branches. We have square root of 9 and square root of negative 1, which would be 3i. We still have this plus or minus in front, so our final answer is x equals plus or minus 3i. Okay, now we're going to move on, and we're going to start adding and subtracting real numbers and imaginary numbers. So a complex number is any number that can be written in the form a plus bi. So what that means is the real number has to come first and the imaginary number has to come second. So if I add, I'm going to combine like terms, and I'm going to use a highlighter to do so. So I'm going to highlight the like terms, right? Those are numbers, real numbers. And then I'm going to add the i's together, making sure that I grab the sign in front. So I can add the pink highlights. That's negative 5 minus 3 is negative 8. And 5i plus 8i is 13i. And that's it. It's in this form, a plus bi, right? The real number and then the imaginary number. You cannot write it in reverse order. You have to write real number first, imaginary number second. So if I look here at example 8, I'm subtracting. So I'm going to think about this negative like a negative 1 that I'm going to distribute into the second parenthesis. It's a very common mistake students make. They forget to distribute the negative. So I'm going to rewrite this equation, 8 plus 3i. I don't really need the parentheses after I distribute, so I'm going to leave them off. Negative 1 times negative 10i is positive 10i. I'm going to highlight the real numbers and the imaginary numbers, just like I did last time. So real numbers, I have 8 minus 4. And then the imaginary numbers, I have plus 3i plus 10i. So if I combine the two real numbers, the pink highlight, 8 minus 4 is 4. 3 plus 10 is 13i. Again, I know I'm in the correct form because I have real number first, imaginary number second. Okay, that is it. Your homework is page 165, 1248, 1416, 2526, 28 and 30. That's 10 problems. So know that when I return, I'm going to check your notes to make sure you've taken the notes, and I will check the homework. I'll see you guys next block day.